And as you do this, 7 factorial over 7 minus 3 factorial. You got to be careful that it's not 7 factorial over 3 factorial. Okay, that's not true because that would give us 7 times 6 times 5. Okay, what that would give us though here is 7 factorial over 4 factorial. And why does this come out to be the same thing? Okay, I chose a problem that I could show you how it cancels. Okay, and 4, the 3, the 2, the 1 are going to cancel, leaving you with just that. So what's the big difference here? If I have, that as a permutation right there, C7 pick 3, that's a combination. How does that make a big difference? If I was just, I know the answer is going to be different, but what's it really mean in English difference when we're looking at a pattern? So if I have a group of 3, if I picked these 3 right here to be in my group, okay, my favorite students in the class, these 3. Doesn't matter who out of these 3 favorites that I pick first. Now, if I have 3 favorite students, okay, then doesn't matter if Daniel's number 1, okay, and Tia's number 3, they're still in that same group. So this right over here, okay, order, okay, does not matter here. So what I'm going to have here is I'm still going to have 7 times 6 times 5, and I'm still going to get 210, but what do I have to end up doing? Divide by why 6? It's how many ways can I organize? I have that many ways, 3 factorial ways, too many, that I can organize. Well, Daniel's first, okay, then Noah, then Tia. Well, Daniel can be first, and then Tia, then Noah. Well, that's how many ways that I've switched them around and saying who's really my most favorite. Well, there is none. Okay, just like, those of you that have brothers and sisters, there's always a favorite kid, right? Yeah. Oh, everybody's supposed to be equal. That's what your parents tell you. All right, so we have 210 divided by 6. Okay, gives us, is it 35? Yeah. 35 ways, okay, to pick if order does not matter. How you do that with a combination? 7 factorial over 7 minus 3 factorial. Okay, then you have that 3 factorial in there. So it's the same thing as I had right up here. 7 factorial over 4 factorial. I get that same thing I did, okay, right here. Okay, but then I have a 3 factorial in there. That's still going to give me 35. Okay? We're going to do some different word problems, not just in the number format, but that's kind of what I'm going to go back and forth. Some of them are permutations and some are combinations. So I think that's probably what most of you are going to look at. I mean, how do I know when I use what? Kind of recognize what's it asking. Does no order matter or not?
In those circle questions, like business circular, how come it's all like, see the one on the worksheet, it was like a bracelet, there was 7 charms.
Yeah, if you're gonna do that, you have 7 charms. 1, 2, 3, 4, 5, 6, 7. Okay. See, what's going to happen here is, as I numbered these things right up here, I can stick this. Is that still the same order? Yeah. Is that still the same order? See, I have the number 6 up here on top. So I do have here 7 factorial, but I have 7 ways that I can rotate this all the way around that it's really in the same order. So this is not 7 factorial ways, this is just 7 clicks that I'm moving it around. So that's why this is just a little different than before. Yeah, that's the formula for circular patterns. It's n factorial divided by n for circular patterns.
Go back to the last problem. Just curious how you got 3 factorial divided on the problem.
Because if I have 3 people, these 3 people right here, and they're a group, okay, my 3 favorite students, does it matter who's number 1 favorite? No. So when I pick people, like I said, I picked Daniel
Oh,
here
I-
first. It doesn't matter who's first. Okay, they're in a group of 3, so I had to take that into account and divide that way to switch those 3 people around out of that 210.
And how can you tell if the order matters?
Practice? Yeah, no, I will not. It will not say combination, it'll say permutation. It'll say, this is a sundae and I want to put toppings on. Well, it doesn't matter when I put chocolate or vanilla on, it's, you know, they're the same. And I put vanilla and chocolate on, they're going to taste the same. Okay? You could argue it, but you got to kind of understand it. You know, just like this one we did this yesterday, right? So that was this Sunday. Okay? So here's another one right here. Okay, you have to determine right up here, okay, when you look at that one, I have 5 students that will be selected today who receive no homework. My most favorite is students. 5.
So I guess that's
Okay.
This is true.
This is not true, but it would be fun to be able to pick my most favorite one. Watch the rest of you get really mad. Okay, how many ways can I select these students? So it looks like we have 5, 10, 15, 19, 23 students in this class right now. So I have 23 students in my class, and I got to pick 5 of them today to give no homework. You're definitely not going to be selected if you can't get this problem right. Because you're not my favorite, but if you can miss it.
You're looking and smiling at me. That tells me something good. Or perhaps something bad.
What's that? There's 23 people in this room right now, and I get to pick 5 people to reward them with no homework. There better be 5 people that get this problem right. So when I pick these 5 people, I guess the question is, when I pick them, does the first person get rewarded more than the 5th person? So does order matter on being selected first to get no homework than to get last no homework?
Nope.
So is this a permutation or a combination?
Combination.
This is a combination. So yeah, it didn't say it in the problem, combination, but it's something that you got to kind of recognize. Oh, this is that type of problem. Combination. We have 23 students, and I get to pick 5. Now, you're more than welcome to be a formula-oriented person, but I really hesitate when the problem changes a little bit. I don't know how to use the formula now. Okay, I have 5 slots right over here to pick for my favorite 5 students that don't get homework. How many people can I choose to be the first person? Okay, 23. Then I have 22. Then 21. Then 20. And then 19. I multiply all those together and I get this really big number. What'd you guys come up with?
4037.
Whoa, too much.
40.
I got
37.
30.
40, 37,
880.
8,
Oh, that's 80.
80. Okay, so 4,037,880. You guys got that? How many times those? So is that the number of ways that I can select people? No, because order doesn't matter here. I have to take into account those 5 people. I can't reorganize them and say, oh, I picked you first, now I'll pick you last. You still get rewarded for no homework. So you have to take and divide that by the 5 factorial, not just 5 ways, but the 5 factorial ways I can reorganize just those 5 people in the selection process. Okay, so I basically 5 factorial is in 120.
Yeah.
So I have to divide that out of this thing. Okay, and what was my final answer? 33,000? 649? Okay. Alright, so if you're back here and you're saying, well, what couldn't I have just done this formula? 23 factorial over, just be careful. I have a lot of people put 23 factorial over 5 factorial. Okay, 23 minus 5, that factorial, and then you have to add on that special, okay, 5 factorial that's in there. So yes, it's 23 factorial over 17 factorial, 5 factorial. The reason I do not like formula people, okay, oh, 18, yes. The reason I don't like formula people is because some of you are not as smart as the calculator. and you type things into your calculator, and you will type in, and I'll go ahead and do it, okay, into my calculator. What was the answer I was supposed to get again here again? 33,000? Okay, so I hit here, 23. Okay, I hit the math key, go over to probability, gets 23 factorial divided by 18 factorial. Okay, times 5 factorial. You know, you have to be as smart as the calculator is going to be. The calculator knows the orders of operations, and apparently, if this is what you're typing in, you do not. Because obviously that is a lot bigger, because what you did is you took 23 factorial divided by 18 factorial. You got this big number right here that I had 4 million, and then you actually times it by 5 factorial when you're done in your calculator. You have to physically put parentheses around that if you're going to use your calculator. Okay, so both of them will be handy to know. Here's the logic behind it. Here's the formula behind it. Okay, which one you remember in the long run? You know. Okay, they're both handy.
Could you also put it in 23 factorial divided by 18 factorial divided by 5 factorial? That also work.
Yeah, that would work. All right. Question here is about cell phones. Okay, so if we're talking about a cell phone that have to have an area code 319, I want to know how many different possible cell phone numbers that are possible here in the 319 area code. So out of all the companies that have them out there, how many combinations, how many cell phones could they issue in the 319 area code? Now let's think about this. So in the 319 area code, you have to use 319, and then there's going to be how many digits after that? 7 digits. Okay, that's going to be total that we have. Now there are some things that you may not know about cell phones, or actually numbers that they don't allow. Okay, this number right here. Okay, usually they don't allow 0 there. Okay, because that's usually the number for the operator. They usually don't put 1, okay, there, because that's no 1. They dial long distance sometimes. Not on cell phones, okay. They don't use the 1 or the 0 here. So I'm going to keep that consistent. Okay, so you cannot use 1 or 0 for that number. Okay, now, in the last hour they said, well, you'll never see them use 911 for that. Okay, let's not go there either. That just makes the problem more difficult. We could go there, but let's keep it. So I just want to know how many possible combinations right there can you come up with? It could be all the numbers you want up there after the first 2 numbers can't be 0 and 1. Because heavens forbid you have to actually use your calculator right now. If you gotta push your buttons. Does order matter on this? Okay. Right now, we have to come up here and, okay, well, it actually said no. Order does matter on this, okay, which one comes first. So this is a permutation. Okay, permutation right up here. Okay, however, when you're doing the permutation, okay, it's unique because you're not using a number and it's not, you can reuse it again. So like in this first one right here, how many possibilities do you have for this first number? 8 here. Now how many do I have for my next number? 10, and then I can reuse that number again. Okay? In part B, I'm going to let you repeat them. Then I can reuse it again, and again, and again, and again. And the reason I gave you such a hard time, for those of you that use your calculator, is because 8 times 10 times 10 times 10 times 10 times 10 times 10 is how many zeros? 6. Okay, so there's 8 million ones. Okay. Really what I was getting to is if you can't repeat things. Same rule here, you can't put 0 or 1 there. You can't repeat it. So no number is allowed to be repeated in a phone number. So you know that, just like this one, 0 and 1 can't go in that spot. So there's still going to be 8 possibilities here, because 0 or 1, okay, still cannot go there. But the next number, how many choices do you have for your next number, since 0 and 1 can't go in the first one? Have you picked a number for your first slot? You picked it. It wasn't 0, 1, I know. It was, let's say, 5. So now if I picked 5, how many numbers do I have to choose from for my second number? 9. 0 and 1 are back in the mix now. So I can't use 5 because I made that one up, but I have 9 left here. Now, how many numbers have I chose from so far? I've chosen 2. So how many do I have left for this third number? 8. Okay, then I have 7, and then 6, and then 5, and then 4. Okay, times all of those, okay, together. What do we get?
48, 38, 40.
48, 38, 4. Okay, so 483,840. Yep. I'm just curious, what happens if US Cellular decided that they can only have the prefix 521? How many numbers are possible then if US Cellular is like assigned? In Iowa, 319 has to be 521. How many cell phones could US Cellular give out here in Iowa in the 319 area code? You can do this in your head.
42.
If they had to have, in the 319 area code, US Cellular had to have the prefix 521.
10,000.
1, 2, 3, 4. How many numbers are left for those 4 digits? 10 times 10 times 10 has 4 zeros. Just 10,000. Okay, yeah. I don't know, 10,000 people in 319 area code? I don't know how many they give up, but who knows? All right, so the Lakers played last night. They were up by a lot last time I looked. But here's just a problem about rosters here. If you don't know anything about basketball, this is a basketball game. If you didn't know who the Lakers were. Okay, basketball has 5 people on the starting roster, and I don't care, okay, position-wise and who plays where. Okay, so you don't have to worry about, I have a guard, I have some forwards, okay, I have a center. Okay, you don't have to worry about that. You see 5 people to dress from the Lakers. They're going to beat anybody anyway. Okay, so you have 14 people dressed on the roster right now. Choose 5 people to play and see if they can win. Go ahead and figure it out. How many different lineups could you get? Still like those of you that are just kind of thinking it out. We got 5 places. Okay, and I'm coming up here and I'm thinking about this. There's 14 people to be picked first, and obviously 13 and then 12, and then 11 and then 10. Okay, I multiply all those things together. What did you guys get when you multiplied all those together? 20,000? 240, 240. Okay, 240,240. Okay, now, is that my answer? Okay, it doesn't matter, right up here, you pick your first 5, it doesn't matter who I'm picking as the first and who I'm picking as my 5th person in my lineup. They're still out on the floor playing. So it's still the same lineup, because I told you it didn't matter who's playing in what position. Okay, so this right up here, was it a permutation or a combination? Combination. I had 14 people, I got to pick 5. Okay, so this is 14 factorial over 9 factorial. The magic thing you have to do is divide this amount by the 5 ways you can organize, okay, those 5 people you chose. Okay, and I believe as I walked around, you got 2,002 different ways I can make 11. Okay, and they'll still work. All right, we got 2 left here. We'll take our quiz. Find the number of groups that can be formed from 9 juniors, 11 sophomores, and 13 seniors. Okay, the group must have 6 total members.
Is this like the cafeteria work?
A little bit. It's,
Doesn't matter.
doesn't matter who's in one. You know, if we don't like the seniors, then we don't pick any of them. So it does not matter your makeup, who's in the group. You can have it all juniors, or you can have it all sophomores, you can have it all seniors, or a mix of 1 or 2 or all of them. So if you have 6 members, you gotta look at 1, 2, 3, 4, 5, 6. And you choose them right now. How many do I have to choose from as the first person I choose for my group? How many do I have to choose from? There's no 33 up here. There's 13, 11, and 9. Okay. You have to find out, okay, how many total people there are. Because in this group, it doesn't matter, what class you're in. Okay, it just means that I have 33 people to choose from. Then the next time I have 32, then I have 31, then I have 30, 29, and then 28. Now the question is does order matter here? So is it a combination or a permutation? Okay, so this is a combination of 33 people, okay, and I have to choose 6 of them. It should be pretty big, because this right here in itself is going to give us, they're pretty big. So, what's that? No, I don't think you'll have a half a person. If you get a half a person, we'll put you in that category.
So, how would you make that question?
You don't want to be in that category? You'd be a category all by yourself, though. All right, when you multiply these together right here, what do we come up with? 2, 7.
Oh, I know what I did. Okay, now I know I got
797 448 960. All right, so we got 797 million. Okay, now the problem is when we choose these people, okay, order right here doesn't matter, so we had to divide by 6 factorial, which is 720 ways. Okay, and that will give us, again, that's the same thing as 33 factorial over, okay, 27 factorial, 6 factorial. Okay, and that'll give us the same thing. And somewhere around 1 million something, right?
1,107,000.
How would you make that a permutation question? You would have to say the first person that I choose is going to be the president. The second person that I choose is going to be the vice president. Third person I'm going to choose, and I have 6 categories that I have to choose them from. So then it matters who I choose first. Kind of like this next question right up here. Okay. This next question, I'm going to take the same category right here that I have. It has to have 6 total members again, okay, but 3 of them we need to have 3 seniors, 2 juniors, and only 1 sophomore.
Sorry. Inside joke.
Okay?
Wait a second, there's already a 6 factor group that's basically saying.
This is a different problem than what we just got to do. I have just made a specific arrangement of saying, instead of having the possibility of all sophomores, I want to now have the majority of the people be our seniors. Okay, then, hierarchy here says, okay, now we do the juniors. So we have to deal with this in 3 categories. We have to deal with the seniors. Okay, then we come up here and deal with their juniors. Okay, and then our last one is dealing with our sophomores. Okay, so in our senior category, how many more are we going to do? 3. 1, 2, 3. How many of them do we have to choose from? 33?
13.
Okay, now we don't go 33 because we're specifically saying in this category of 3, and only seniors belong in the category of 3. So we have 13 people to be chosen first, then 12, and then 11. Is this a combination or a permutation? Does it matter who comes first? It does matter who comes first? No. It's a group of 3. Doesn't matter if you pick that person first or you pick them last, if they're in the same group. So it's still a combination of 13, choose 3. So when I'm done here, okay, I'm going to have 13 factorial all over 10 factorial, but I have to divide by what? I have to divide by 3 factorial. Okay, I need someone just to multiply 13 times 12 times 11 from this. 1,716. Okay, now that's the total number of ways that I could organize them. But we know that we have to then divide by the 6, the 3 factorial. Okay, so our final answer that we get here, 286. Okay, different ways to deal with just our seniors. Okay, our juniors. Juniors, we have a combination. How many do we have to choose from?
2.
We only have choose as our juniors, but we have 9 to choose from. So we have 9, choose only 2 of those 9. Okay, so again, this is 9 factorial over 7 factorial. Okay, but again, you've got to remember to divide it by the 2 ways we can switch around. You can pick person A, then B, or then B, then A. Okay, that's a different combination all the way through the 9 people. So this is 9 times 8, which I know is 72, but I have to eliminate the 2 factorial ways of organizing them. So it looks like, do that one in my head, that's 36, right? Okay, and now our most important people over here. Okay, our one single sophomore. Yes, you can come over here and do a combination of, I have a total of 11 sophomores, pick 1. Yes, you can come over here and do 11 factorial over 10 factorial times 1 factorial. You are more than welcome to use the formula. However, there's one spot. How many people do we have to choose from? 11. And we know this right here is going to come out to be 11. Okay, so what do we do now? I have 286 seniors, 36 juniors, and 11 sophomores. Now, what you have to realize here is I could have the set of seniors, let's say set A of seniors and set A of juniors. Or I could have set A of seniors and set B of juniors. Okay, if I have different sets, I have to multiply the different ways that I can combine them together. You're not just saying I have this many here, plus this many here, plus this many here. I can have a different set of juniors with this set of seniors. Then I have the number of sophomores. So I have to take and multiply, okay, the 286 over here times that 36. And multiply by the 11. What was your answer?
113.
200 and what? Any questions here about permutations and combinations? The questions were answered at the beginning of the period. How do I know? Should I clear it up a little better? And there is no way to say, it's not going to say in there, this is a combination problem. Okay, you just got to kind of look at it and see. Kind of compare. I think the easiest thing to compare with is, your pizza problem, okay, your Sunday problem. So you can see those things. If I put them on, food's food, okay, it should taste the same no matter how you dump the toppings on.
So these problems are not just that.
Pizza problems are combinations, because it doesn't matter if you put pepperoni and sausage or you put sausage and pepperoni. Okay, it's still going to be the same pizza if it's two topping pizza. Okay? Yes. All right. What I need you to do is get out both your permutation worksheets. Okay, done or not done, you're going to hand those things in. Okay, up here while you are taking your dues. Okay, I am going to grade them.